Sai Ram. Hearty welcome to this session of Study of Science for this segment of 9th standard. What is this science all about? Science is nothing but study of the nature which is present around us. It is just the study of whatever we are able to see from our eye, but definitely there are things which we cannot see from our eye but still they exist. So this entire study of science depends on the visibilities of our eye as well as the non-visibilities of our eyes. So in this segment we are going to study about something called as matter. Matter in our surroundings. So what is this study all about? Let us go through in this entire session. To start with, everything in this universe occupies space and mass. It occupies a certain space. In this process, you can take your own example. Where are you present now? Probably you are sitting down, you are sitting in a place, or you are standing. Wherever you are, there is some sort of space that you are occupying. What is your weight? This is a general question which is asked by people. This aspect is nothing but mass that we have of our particular body. And this general explanation doesn't restrict to only our bodies as such. Even the non-living elemental parts can be explained based on having space as well as mass. So anything that occupies space and has mass, we tend to call them as matter. Matter is something which has mass, also occupies space. Now in this case we come across two forms of this, where one form we call it as physical form, the other form we call it as chemical form. What is this physical and chemical? Chemical, if you know by a general sense, it deals more with reactions and all, which we will study in the further parts. But the physical form which is there is nothing but whatever we are able to see with our eye. So in this segment, we will basically try to concentrate on the physical forms of these sciences, and especially in the case of matter. So moving ahead, we shall now see what is this physical nature of matter. In this physical nature of matter which has been present here, we come across some segments, words like sky, air, water, fire and earth. We have come across these words n number of times till today. What is sky? Something that is present above our head. Something which protects us from various strong radiations coming from the space. Also, it has an atmosphere. What is the next segment? Air. Can you live without air? Definitely not. Oxygen is the basis of the very living organism, and air forms a very important component of what we breathe. The next aspect is water. How many days can you live without water? We happen to hear some freedom struggles where some people lived for many days, 30 days, 40 days, 50 days without food. But without water, you can't last long, because water is a solvent which runs in our body and makes it run in a very comfortable biological process. Moving on, we have fire, the very form of energy. Energy is an important component that you come across for any work to be done. And this fire aspect which is there is a form of energy which we generally tend to use. Finally, the earth. What is this earth? Something on which I am standing for now. Something which offers us a place to live about. It also has many things inside it. If you remember, we have extraction of metals and all. We use aluminium metal, we use copper, zinc. All these are present inside the earth's crust. You are going to dig open the earth's crust and then you are going to get these materials. So this earth forms the very basis of our living conditions which we are there. So if this is the physical nature of the matter, there happens to be a figure which is present along with this. It just shows these different 5 elements in various forms. There's a man in between there. What does this signify? The very sustenance of the man is dependent on all these 5 factors for physical existence. But then our bodies are not just meant for physical existence. We got to evolve as a human, and these 5 properties of nature which can help us for physical existence, our goodness and greatness can help us to evolve over a period of time. So these physical properties are responsible for a smooth living of individuals, living organisms, and remember that even non-living organisms are present in the same conditions. The non-living organism also tend to have their sustenance on earth itself. So moving further now then. What is this? We already saw what is matter. What is matter? Matter is something which will occupy space and has mass. Now the moment you say has mass, you got to specify it. What is the mass? Is it too high? Is it too low? What is the quantity? We do not know. So once we start experimenting on these things, we get an idea as to what could be the major constituents of mass. In this factor, let us now come across where I have an experimental setup which consists of a beaker. This component we can call it as beaker. Something which can hold any liquid or solid in it. For example, I have taken water in this parts. This water is probably having some quantity. It may be 50 ml, it may be 100 ml, 1 liter, anything. For this experimental condition, let me believe that this is around 50 ml. To this water, remember that there are a lot of molecules which are present. It's not that water is made up of just one molecule. So many molecules get together and form each and every living individuals as well as the non-living components also. So this water which is there, supposing if I add a spoon of salt. This experimentation, for example, I have taken salt, but I can also take an example of sugar. When I add sugar to this system and maybe utilize a little more stirring for proper mixing up, what I realize after some time is that I don't see the salt at all. There is no presence of salt. Does that mean it has vanished? Definitely not. Whatever salt you happen to add in this case has dissolved in this water, thereby giving a salt solution. You may not be able to see the salt by your own eyes, but please take a sip of this solution into your mouth. You will find a difference in state. What happens when you mix sugar in water? You get the taste of a sugar solution which is seen to be pretty much sweet. So this sweetness is obtained because sugar molecules were mixed in water and completely dissolved in it. In this example, salt was mixed in water and thereby you got a salt solution. For your naked eye, this looks like a clear water solution only. But on having a taste, you will realize that this compound is a mixture of salt as well as water. So what do we understand with these parts then? It means that the water that you happen to take, I am sure you are able to recognize some molecular forms which are being shown here. And these molecules are not tightly packed. As they are shown here, there is some amount of space which is available in between conditions here. Your salt which you added actually went in and occupied this spaces which were available, therefore you could not see the salt at the fag end and it was all dissolved in water. Supposing the water didn't have space between them at all, then you would not have mixed the salt in water. Why does salt mix in water? Is because water has space between them and the salt molecules occupies those spaces. So by this experimentation we realized that this matter is made up of many such particles like water molecules or salt molecules and all. Alongside this, we could also understand that these systems which are there probably had some spaces between them, and when we added an external substance like salt, it got mixed properly. So moving further now then, we'll see the next one. What is the next experimentation we are up to? This is a setup, and probably by looking at this, you may be able to analyze what is happening here. There is some solution which is taken here at the start, and suddenly there is a change of color that you are observing all around this parts. So seeing in these conditions, we have that this solution which is present here, we have added some quantity here of some solid material. What is the solid material? This is nothing but this is KMnO4. K stands for potassium, atomic number 19. Mn stands for manganese, atomic number 25. Oxygen, O stands for oxygen, atomic number 8. All this can be obtained as an information from the periodic table. This compound KMnO4, when you add it to the solution, you got a bright colored solution in this case. Slowly when you went on diluting these parts, what they have done here is from this 100 ml, they have taken now 10 ml of this solution. They added to the next beaker and they added another 90 ml to form to a total of 100. Just to repeat it again, from this 100 ml, they have taken out 10 ml of the solution, added to the next beaker, and they have mixed water. Moving further, once again there is a dilution by taking just 10 ml from this and adding another 100 ml. Further they have done here. What do you understand or what do you see from the systems is that these parts which are there, starting the intensity of color is pretty much dark. Later on it has gone diluting, and if you see the intensity in these conditions is pretty low. What we can understand by this is with every increase in transfer, the molecules are able to pass on to each other. This can also be observed if you mix a little bit of Dettol in water, and if you keep diluting, you still get the smell of Dettol when you dilute it in many such further beakers. Now after this, let us see some characteristics of particles of matter. So what are the characteristics as such? What do we mean by this terminology called as characteristics? Characteristics is nothing but the inherent properties of a particular system, and the system that we are considering here is matter. I as a person has certain inherent characteristics. I have my own way of responding to people. I have my own way of living. So these matter which are there, they also have certain characteristics between them. What does the first characteristic say? Let us just go through these parts. Particles of matter have space between them. This is exactly the same thing which we happened to see a couple of experiments before. The salt was mixed in water because there was space between those water molecules. So like this, these particles which are there, they definitely have some spaces available between them. What differs is some people may have too much of space. One particle may be here, one particle may be here. Some people may have lesser space between them. So the amount of space may differ, but they will have spaces between them. In the next part now, particles of matter are continuously moving. Why can't they be stagnant or be at a particular place? These particles are in random motion, the reason being that for the particles to be existent in nature, they will have some energy within themselves. If this matter becomes stagnant, then there is no life sustenance. We know very well the property of earth. Every single moment it is either spinning on its own or moving around an orbit. So the motion of this earth defines our very living. These matter particles also, they have a continuous sense of motion. Maybe light an agarbatti, an incense stick. What do we see in that? We light that incense stick at probably our puja room, and for some time till the incense stick gets burnt up, we get that smell to certain distance, not to a large distance. It is only available to a certain distance because when it travels, the smell travels, after some time it gets one with air. So therefore, these particles of matter are seen to be having a continuous motion between them. Also, these particles of matter attract each other. What is this? Attract each other. If they were not attracting, every system would never have been together. So supposing as an example, the chair that you are sitting, on that chair, the molecules are attracting towards each other. That is why it has regained a particular sort of shape. Otherwise, if the molecules were not attracting with each other, you would never have a particular system within each other. That is why these characteristics happen to be of importance for these particles of matter which are being present. There is a small diagram which is seen on the other side where similar bottles are taken. The notation given down is cold and hot. This side it is represented as a cold beaker, that side as hot. What it essentially means is the beaker is the same. We have taken water as a solvent. Now water is a universal solvent. What do we mean by this? Universal solvent, the solvent molecules are those which have the capacity to dissolve other species. Salt was able to dissolve in water. Sugar is able to dissolve in water. Similarly, as an example, we have taken ink. Red ink, blue ink, any ink that you have, if you can drop in one system containing water. If it is cold, this is an experimental observation which you can definitely try out. You will see that the ink will spread on a slow basis. It will not spread suddenly. But if it is a hot solution, it spreads too quickly. What do we understand by this system? What is this cold and hot system? Cold system is those where the molecules which are there are present as itself and they have very less energy. Once you increase the temperature, what do we mean by increasing temperature? It means that we are offering energy. So once energy is offered, these systems, the molecules will vibrate within themselves. Why molecules vibrate is because when you offer temperature, when you make it hot, you are supplying energy and therefore those systems will have more energy and they will vibrate. Therefore, the dissolution is seen at a faster rate. What we understand by this is that particles of matter have kinetic energy, but if you supply temperature, if it is made into hot solution, the kinetic energy will increase. What is kinetic energy? The energy in motion. That energy will see to it that the particles spread along at a faster rate. Moving forward now. So states of matter. We have seen what is matter. We saw many examples. We saw an example where salt was dissolved in water. The KMnO4 solution was mixed in water. Dettol solution was mixed in water. We also saw hot and cold differentiations in these cases. But what are these different states of matter that we come across? We broadly classify them as solids, liquids and gases. So what is the solid, liquids and gases? In the first set of alignments that we come across, these solids have a definite shape. Any solid that you use, Again going back to the same examples, table, chair, or any movement and all. So all the solids which are there, they happen to have these systems. So they have a definite shape because the molecules are tightly packed between each other. But what happens in the case of liquid? In the case of liquid, they take the shape of the container. Half a liter water if you have, you put it in the glass, it takes the shape of glass. You put it in a bottle, it takes the shape of bottle. You take a bucket and put water in it, it takes the shape of bucket. So these liquids do not have their own shape, but they take the shape in whichever quantities you add. Similar is the case with gases because they also do not have their own existent shape. They occupy the entire area that is being present. So wherever we live, there is air around us, but molecules do not stay at a single place because in solids, the molecules are tightly packed. In liquids, they spread a little. In gases, they move all around the system. This is how one of the property can be discussed. The second one is that they are tightly packed in nature, which I have been explaining you, whereas this is loosely packed and this is thoroughly randomized because the attractions are comparatively less in gases. The third point, it has a definite volume. Both these people tend to have a definite volume, but they say that gases do not have definite volume because solids have a particular shape. Liquids, whatever be the size of the beaker, supposing you take 1 liter beaker, but if you use only 500 ml of water, it will take the area of only 500 ml of water. So considering this as a beaker, if I take 500 ml of water, only this much is filled. But the same thing in a beaker, if I use a gas which is present, it will not occupy just the lower half. It will occupy the entire container. That is why we happen to say that there is no definite volume for these gases. Moving further, diffusion is slow. Why diffusion is slow? What is diffusion? Diffusion is a mixing up of two people. So here in solids it is slow because molecules are tightly packed. In liquids it is a little faster, whereas in gases it is the fastest among when you compare the states. The reason is because these particles which are there, gases being far away, there are more spaces, so therefore they can mix up with each other. Finally, certain examples like pen and book, these are solid forms. Water, oil, milk, these are liquid which can actually flow on a surface. You put water, oil and milk, they can flow on a surface, but solids cannot. Whereas gases, LPG, CNG, best used in our domestic kitchens. We use this LPG gas for cooking and all. So these are the certain states of matter that we come across on a regular basis in day-to-day life. Are these all the states of matter? Are there any different states of matter also possible, but probably we have not studied much? Let us see that in the further segment then. As I happen to tell you, our major studies revolve around solids, liquids and gases. And these happen to be more available around us. But of late, these are the states which are being found out, where one is called as plasma, the other one is BoseEinstein condensate. First, let us just have an introductory part of this as to what is this. Studies of this has been very minimum. But what is plasma is, these are highly energetic particles which are present, which are being formed by ions of gases. Now what is an ion is those particles which will have charges. This plasma content which is there is made up of very excited, highly energetic ionic particles which are there. Similarly, we have another condition where another state which is called as BoseEinstein condensate. This was actually a work together by an Indian scientist Sathya Bose and a very well known scientist Einstein. Now what is this condensate basically is, the gas molecules which are there, remember the molecules of gases are far away. This we have already studied. So those gas molecules, so they are being compressed and very less density, very low temperatures are maintained. What is the temperatures that we stay in? Probably it is around 25 degree to 40 degree. Some of you may stay in colder regions, might be around 10 degree, 15 degree, 20 degree. But these are not at these conditions. This sort of a state of matter is obtained at a very, very low condition. Now why there is not so much of discussion about this is because these are just found out and the research is at preliminary stages. There's still a lot to work about this, lot to find out about this. So for your level, we just offer an introductory part that along with solids, liquids and gases, there are other possible states of matter which we call it as plasma and Bose-Einstein condensate. So next segment now. Some case studies about solids, let us see. We have seen what is example of solids, pen, book and all we have seen. Some general examples we know. And since from young age we know this basic difference of solids, liquids and gases. But let us do some study with respect to certain materials now. The first example I happen to take up is a rubber band. Is it a solid? Is it a liquid? Or is it a gas? Generally, once you touch the rubber band, you will realize that it has certain solid aspect. But you always try to stretch it. Does it get stretched? Yeah. Actually, solid molecules, we assume that they should be tightly packed, but rubber band does get stretched. Now that is because there is another property in solid called as elasticity. So in general terms we call it that elastic in nature. So this elasticity which is there, this is an important component where the rubber bands we are able to stretch it, and then once we leave the pressure, the rubber bands come back. But if you offer excess of pressure, then it will break open. So realize that rubber band is a solid. So if I have to represent the rubber band like this, there is space between the solid, but this rubber band particles which are there, they are tightly packed with each other. Moving on to the next segment now. In this case, so we talk about sugar or salt particles, they remain fixed. So supposing you take a jar, you realize that if you fill sugar to this component, it will show so much. You take another jar, if you fill it to the complete brim, it is taking so much of volume. This actually, if you remember, we discussed it under liquids, that liquids will obtain the shape of the container. But here we see that depending on the quantity of sugar, it is obtaining the shape of the container. You use a bottle, the sugar also will take the shape of the bottle. So should I call that as a liquid? No. Sugar may take the shape of the container, but remember that it is a combination of many particles. But every sugar particle, dane ka sugar which is there, that is a minimum particle size which is there, and that is a solid. Many particles together may obtain the shape of the container, but individually they are solids. Moving further now, sponge. You press it, it does go inside. But solids, we tend to say that the molecular arrangement is solids is tightly packed. So will you classify sponge as a solid? It is classified in solids. The difference is that layers are being present, and on those layers, so when we consider this type of layers as such, the in between layer parts has spaces between them. Those spaces which are there will be compressed when we put pressure on it. As we put pressure on it, this empty spaces which is there will compress themselves. Remove the pressure, you will see that the sponge regains back to the same condition. So more or less similar like rubber band, but here rubber band revolves around the concept of elasticity, whereas sponge has air particles in between them, empty spaces between them. When you press it, it compresses. Open it up, it will again regain back its state. So these are certain case studies of solids that we happen to come about. We will now see some examples of liquids and gases as case studies. Water and cooking oil. Supposing you spill it on the floor. Water travels very fast, but cooking oil particles, you see that they travel slowly, which means that every system has different molecular arrangement. If the space is more, it will travel at a faster rate, but if the molecular space is a little tightly present, the travel on the space will be reduced because more molecules are condensed together. So we see this as a regular example that this water and cooking oil, if at all we split up in general cases, we spill it on the floor, it travels at a particular pace. Similarly, we also see that water actually dissolves many compounds in itself, and therefore we call that as a universal solvent. Majority of the compounds get dissolved in water. Also talking about gases, about a balloon seller selling many balloons with just one cylinder of a gas. Probably a gas cylinder, if you see, it has written markings of around 14.2 kg or 16.2 kg. We get it at domestic usage as well as general usages. But you see that they actually fill a lot of balloons with that. Your mother will use the same cylinder depending on the number of people, say for 15 days, 1 month. How is it that one cylinder is able to have so much of content of gas in it? Now that's because gases are easily compressible. What do you mean by this factor called as compressibility? Compress means molecules of gases are freely present all across. So what you can do is you can compress them and store it together. So whenever you want to use this gas, small quantities of gases will come out. Finally, we see a last point here which I have put up. We come to know about the tasty food being cooked in the kitchen without even entering there. Now why is that possible? Because your food which is cooked is normally on a stove at a higher temperature. I have already specified you that higher temperatures will give more energy to kinetic energy to the molecules, and therefore when you are there at a particular place, you will see that the smell of the food is reaching much faster to you. These are certain case studies that we tend to do for solids, liquids and gases. Let us see a representation of the solids, liquids and gases. I have already, as we have gone through, solids have a completely tight arrangement of molecules. All the molecules happen to be tightly packed in nature, whereas liquids, there are minimum spaces which are being seen here. Whereas for gases, you can see large number of spaces. That is because attraction in gaseous molecules is less. Therefore, the molecules spread all along and they occupy the entire area of container. If you make the beaker bigger, they will occupy that part also. Again, as a representation, we have a solid here where you see that it is present as a strong hard base. Liquid, an example is given of water, whereas for gas, we have this entire system in atmosphere which has been present. Let us now see then certain questions which can be followed up in this case. Let us go through these questions, try to answer them. The answers for this will be offered to you in the next segment. All these questions happen to be an understanding of whatever we know in this properties of matter. It just gives us a better view of whatever we have understood. All these are more or less applicative questions. If you see here, smell of a hot sizzling food reaches you several meters away, but if the same food is cold, it will not reach you long. You may have to come near to smell it, or you may not get the smell at all. Give reason for that. A diver in a swimming pool, whenever you dive, you are very easily able to go into water, but can you do the same way inside a solid door or anything? So here the basis happens to be the arrangement of molecules. A gas fills completely the vessel in which it is kept. Give reason. Why does ice float on water even though liquids have lower density as compared to solids? For this I would just like to let you know what is density. Density is nothing but it is given by a factor called as, we represent it as D. D is equal to mass divided by volume. For a particular unit of volume, whatever mass is added, so that mass by volume is called as density. Generally, solid density will naturally be more because molecules are tightly packed. So their density will be more. Liquid density will be little less because molecules are far away. Gaseous density will be still less because the molecules are randomized everywhere. But even though we see that ice will float on water, this, if you have a fridge at your home, definitely you can try this out. But scientifically, try to reason it. Hope you have understood whatever we happen to cover up here in this part, and we will again see you in the next segment with answers for this question and further scientific reasonings. Thank you. Sai Ram.